Hello class, this is section 4.4, properties of logarithms. So let's get to it. So this first one says use the laws of logarithms to evaluate the expression. So because of this plus sign, that means we're going to apply the property that says log of a plus log of b equals log of a times b. So in this case, if we multiply the 500 and the 200, that's going to be 5 times 2 is 10, plus 1, 2 zeros, 1, 2, so that's 1,000. All right. Well, actually, no, that's not. That's more. That's going to be 1, 2, 3, 4. That's way more than 1,000. Sorry about that. That is 2, 3, 4. All right, so that's 100,000, actually. All right, so we still need to evaluate this expression. So like I normally do, I always set this equal to x. And whenever there's no base that's written in, that means it's implied that it's base 10. So if there is no base, then you can assume that it's base 10. So I'm just going to fill that in. And now I'm going to convert this to exponential form by crossing out the word log and swapping these two numbers. So base is 10, exponent is x, and that equals to 100,000. And to make these bases the same, I'm going to use base 10. So it's going to be 10 to the 5th power is 100,000. 1, 2, 3, 4, 5 zeros. There you go. And by the one-to-one property, x has to equal 5. All right, in this case, the law that we're going to apply is the one that says log or natural log, it doesn't matter, of a to the p power. You can bring the exponent to the front of the log, and it becomes p times natural log of a. That's exactly what we're going to do here. In this case, we have natural log of the square root of z, which is the same as z to the 1/2 power, because square root means exponent of a half. And now we can apply this property, which allows us to move the exponent to the front. So our final answer will be 1/2 natural log of z. All right. Here we're going to use a combination of all three logs. The one that we haven't looked at is the division one that says log of a minus log of b is equal to log of a over b. So that's what we should do first. We're going to separate the numerator from the denominator. So if you do that, you're going to get log of the numerator minus the log of the denominator. And now we can separate these two bases by using the addition property. So if we do that, we're going to get log of x to the 8 plus log of y to the 3rd minus log of z to the 9th. And finally, we're going to move these exponents to the front. And that will do it. So our final answer should be 8 log x plus 3 log y minus 9 log z. All right. This time we're going to go backwards. We're going to do the same exact thing that we did, but in reverse order. So this is going to move back to the exponents, and then we can go from there. So the new expression becomes log of x to the 4th minus log of x squared plus 1 to the 1/5 plus log x minus 1 to the 4th. And then we can convert, we can combine these two logs into a single log. Because of the subtraction, that means we're going to be dividing. So let's condense those two into one. So that's going to become log of x to the 4th over. And then we can also convert this into radical 5th root because of the 5. So I'm going to do that now. 5th root of x squared plus 1. And then we still have the other log that we haven't worked with. And the addition will tell us that we can combine those two logs by multiplying this term times this term. So that's going to be our final step. We're going to multiply. So when you multiply this times this, there's really an invisible 1. So you're just multiplying the numerators. So that's going to be x to the 4th, x minus 1 to the 4th over 5th root of x squared plus 1. All right, and that should do it. That will do it. So that is the solution. All right, the last problem says, use a change of base formula and a calculator to evaluate the logarithm. So the change of base formula says this. If you have a log base b of a, then that can become log. In other words, you can change the base to anything you want. And generally, since we have our calculators use base 10, we generally want to convert this to base 10. So the way you do that is log of a divided by log of b. So the log of this number divided by the log of that number. And these are base 10. You can make this any base you want, but we want 10 so that we can use our calculators. So now we can convert this into log of 10 divided by log of 7. And if you use your calculators to do that, let's do that now. Log 10, close parentheses, divided by log 7, close parentheses, equals getting, and they want 6 decimal places. That's a lot. So 1.18329. How many decimals do I have? 1, 2, 3, 4, 5. I need one more. Looks like it's 4, 6, so that's going to round up to a 5. So that's what I'm getting when I change the base from 7 to 10. And that concludes this section.